Welcome to Creative Engineering. Today I have a special guest with me. You may know him from Stack Overflow or one of his very popular Flutter packages. I'm of course talking about Remi. Remi, thanks for being on the show. How are you?
Yeah, thank you for having me. I'm doing pretty good. What about you?
I'm doing pretty good too. So today is going to be all about state management and your newest package called Riverpod. To start things off, why did you call it Riverpod?
So it's a provider, but with the letters mixed up. And there's also a second meaning where, in Dart we have streams. And so I realized that by mixing the letters, we could have river in the name. So it's like in the same team. So yeah, there's that.
I like it very much. It's a pretty fun name. So before Riverpod, you created Provider. Provider is used in pretty much all Flutter projects, whether it's directly or indirectly via, for example, a Flutter block. What was the reason for you to start working on this new Riverpod?
It started it started with Stack Overflow. Like at some point, I answered a lot of questions on Stack Overflow, and I realized that the same question was popping up all the time about inherited widgets or people misusing inherited widgets usually. Like they created some state directly inside the build method, but then when something changed, their state was lost because they didn't use a stateful widget or whatever. So what I did was first I answered the questions, but you cannot really fix the problem before people face the issue. So I searched for a different way of solving this problem before it happens. So that's how Provider came up. At that time, it has a provider named stateful provider. So it created it's similar to the syntax with the current state of provider, where you have this create function that creates an object only the first time it's created. So the idea behind it was that people only use this syntax. This way, their state is not lost when something changes. And then, as time passed, more use cases were added, and that's basically how it started.
Interesting. So you touched upon this, and it's a very interesting distinction. What do you think about this? What is Riverpod / provider really? Is it dependency injection? Is it state management? Is it architecture? Because I feel like those three topics kind of bleed into each other, and provider and Riverpod can be used for multiple things or for the same thing. What is your opinion on this?
I know that many people consider provider as not state management, but I quite disagree with that statement, in the sense that even if we are talking about just injecting variables, that's state management in itself. State management is a very, very broad topic. And I would go as far as to say that widgets in Flutter are state management. And when you think about it, they do nothing else but managing states. They're not painting anything. They're not underling clicks. They're just managing the state of the UI. So yeah, in my opinion, provider is a state management. It's just a very specific portion of state management where it's initializing the objects and passing them around. And then we have Riverpod, which has a slightly broader scope, where it's also it's doing a lot of stuff for combining objects and caching results when you're combining things, filtering reveals. It also has some more opinionated things like state provider, which is a very simple provider to create variables. So it definitely has a broader scope, and I think that more people would consider Riverpod an actual state management solution.
Interesting. The reason I was asking, because a lot of use cases are a common thing when using, for example, the Flutter block package, was to use the block package as state management, and block internally uses provider to provide it to its descendant. So the idea with Riverpod is to have the idea of dependency injection and state management more tightly, I wouldn't say coupled, but having a package which is more focused on this. My question in there would be, I've used Riverpod myself for my recent project, and there is a provider which is explicitly used for the state. I think it was a state provider for your state. How's the package called?
State notifier?
Yes, the state notifier. So in this case, if I understand correctly, the state notifier would be the core state management thingy, and a provider would be, not provider, Riverpod would be a way to combine that state, to provide that state, and to manage that state. How would you?
Yes and no. Yes, the state notifier would be your core class to add your typical increment method in a counter, for example. So that's a way where you can center all your business logic inside. But providers also are a place where you can put business logic inside, you can start HTTP requests or things like this inside providers, like typically with Future Provider, for example. You can do a complete pagination system with just using Future Provider with no state notifier or whatever. So you can get really far with this. So I would argue that providers also are state management. It's not just specific to one class.
I see. So it can be used, I guess it's like a lot of topics in computer science and programming. The answer is it depends. It can be used for certain state management things. For some, it might be easier because it doesn't require the overhead.
I would say that the only reason currently why we currently need this state notifier class is because we don't have anonymous classes in Dart. If we did have these anonymous classes, and maybe Dart classes and Silk classes in Dart, we probably could remove state notifier completely and just use providers.
But wouldn't it be possible to have these kind of anonymous classes with functions, with anonymous functions, because you can actually declare functions inside functions and have scope alive?
We can definitely do that, but then it looks very scary and few people would use it. Riverpod already looks quite scary to some people. So I think that if we want to go a step further, it would be too far for some people. I know, for example, that people complained about having too many providers. And while I disagree with Riverpod being complex, I think it's just because it has a broad scope. So people kind of think that it's complex just because there are many APIs. It's very difficult to have something that people would not fear. I think that functional programming, for example, is something very simple if you try it. Especially for example with Elm or other simplified version of functional programming. The tooling helps you so much that you can almost disable your brain and still do things very rapidly because the compiler tells you every mistakes you made. So you just have to almost do right click and fix, and it does the thing for you. But people kind of have this mentality where, oh no, it's functional programming, so it must be super difficult.
I feel like functional programming does all these things for you, and in some way, which might also be a good thing, it makes doing hacky things, like something that has to be done quickly, which just works. It is bad, but it works. It makes it more difficult because you cannot just mutate something, which in turn might be useful if you just want to try out a little thing. You want to build a prototype. You just want to get it out quickly without caring too much about the architecture. I think functional programming makes things like this hard, but on the other hand, it makes it easy at some point to scale, to debug, and to do all of this.
Yeah, I definitely agree with this statement, which is why I think that the ideal scenario when building applications is neither using pure object-oriented programming or pure functional programming, but using kind of like an hybrid architecture instead. Especially, I think Dart is a good candidate, or maybe Kotlin, whatever. So we have this trend recently with language that do both, and where we can get both the benefits of immutability and mutability when you want to. And Flare uses this quite a lot, actually, where with widgets we have this immutability layer. But then if you go one layer deeper with render objects, for example, they use mutability quite a lot to have this very performant API where instead of recreating everything every time, you just mutate what needs to change. So you use both sides of both benefits. Like you have this immutability side for maintainability and this mutability side for performances. And I think it's a good compromise. And that's kind of the thing that's a mentality that I try to add in Riverpod. I think it tries to do the same thing where you could technically, for example, mix mutability and immutability if you want to. You could have this declarative programming where things just like top down and kind of working by itself. Like you write it and it re-execute when it needs to re-execute by itself, just because kind of like with widget, you don't really listen to anything specifically. It's just working by itself just by writing the stream builders or whatever. So at this on one side you have this aspect of declarative and kind of immutability too, and on the other side you can go with I don't know, change notifier or state notifier and go with a very fine-grained control over your state.
Yeah, I really like the idea of being able to adapt these different paradigms, like the function programming and the object-oriented programming, in each other to have like the best of both worlds. Like have, as you said, render objects being these object-oriented state machines, which heavily rely on method calls to do stuff. And on top of this, we just have this functional layer, which harvests all of the power of the object-oriented layer below it, but adds on top of it. That's a very powerful idea. Yeah. Coming back to the actual Riverpod, we briefly talked about this before. You said people felt intimidated by having all those different providers. I can somewhat understand it. I've been reading through the docs and like, okay, state provider does this and the normal provider. So what are the different providers there are in Riverpod? What do they do and why do they exist?
There are a few of them that are. We likely will have more in the future, so I'm not sure that list is really helpful. But the short story is we have provider, just provider, not state provider or whatever, just provider, which is used to create an object that never changed by itself. So it's just like, a repository or an HTTP client if you want to. Or maybe a computed value if you want to, because you could technically listen to other providers when creating a provider. So you could make like a filtered list of to-dos. So you have your provider that listens to the to-do list and listen to the filter and combine both variables to have the filtered to-do list, which will then rebuild only when either of the dependency change. So you get these benefits of not filtering your to-do list directly inside the build method, which is a lot more efficient. So that's for provider. Then state provider is typically for very, very simple states that don't really have business logics associated with them. So like filters from the UI, it's just an enum and you're just changing the enum directly, or switches if you want to. Then by putting this logic inside providers, it allows you to combine this state with other things. So like I mentioned previously with the to-do list example, if you have your filter implemented in a state provider, you can then combine it with the state of your to-do list to do this very powerful filter mechanism. Then you will have your typical business logic providers. So state notifier provider, change notifier provider. Maybe if you're using a third-party packages, I'm pretty sure maybe in the future we'll have block providers, we don't know, which have this fine-grained control over a piece of state where it has methods, maybe it receives events, and it allows you to mutate the state using uses methods and events. It changes over time. And then you have dumbed down versions of this business logic objects with stream provider and future provider, which are like simplified version of states that change over time, but for a very specific use case. So here's just listening to the result of a future or stream. And so whenever something changes the stream, it will update the value. So you don't have to manually subscribe to the stream and then emit the new value. You could do it with a state notifier or change notifier or whatever, but it's just kind of like this boilerplate that you don't really care about. So making a stream provider makes things easier, especially with Firebase, for example.
So basically, correct me if I'm wrong, provider is the base class that can be used to achieve all of this. For example, if you want to have a stream which you listen to, you could just provide that stream with provider and then manually listen to it and do all your stuff. And stream provider adds this abstraction on top of it, which says, okay, we don't provide you with a stream of items, because obviously what you want to do is you want to listen to those. We provide you with every single item, and we will provide it every time the stream that internally emits. So all of the providers like stream provider, future provider, state notifier provider could be implemented with more code with just using provider.
Yeah. Just using provider itself may not be the correct choice. I think the correct choice would instead be maybe state notifier provider or change notifier provider, because these are the most powerful providers. Provider doesn't really have a built-in way of emitting updates, so you won't be able to implement stream provider from provider, for example. But with state notifier provider or change notifier provider, you could do basically everything.
So one thing that I faced when using provider, for example, I had a state notifier provider, and I wanted to obviously listen to the state. So because I was using Flare hooks and a build method, I said, okay, use state notifier provider. So I got the current state. Now I also wanted to access the actual state notifier to call methods on, like update something, delete something. So this time I couldn't just use the state notifier provider because it provided me with the state and not the actual object. So what I ended up doing is just calling, I think it was something like provider off, and then calling the method manually. Would there be a way to say, okay, I want the state notifier, I want all the new states, but I also want access to the objects to reduce boilerplate code?
When you're using state notifier provider in Riverpod, you have a way to specify what you want to obtain. So when you combine it with, I don't know, use provider or the watch method in Riverpod, you can either do like watch my provider, or you can do watch my provider.state. So if you do the former, you will obtain the state notifier instance without listening to the state. So you can then call increment, decrement, whatever. And if you do the later, you will obtain the state directly, but not the state notifier instance.
So just talking all the different providers and the idea behind this, it feels like it isn't too difficult. Like at the end, it just boils down to, when do you want to be updated? For example, with a stream provider every time a stream item is submitted, or do you just want to have the raw state notifier as an object without listening to the states? So you were talking about adding more examples. Maybe it would be interesting to have a little tutorial doc showing how to do something which you could be doing with a stream provider without a stream provider, just using as little amount of providers as possible, and then saying, okay, we did this. This is quite a bit of boilerplate code. You could use this to make it easier.
Yeah, one of the things I'm considering is architecturing my tutorial such that we start without the provider, and at the end of the tutorial we have this refactoring step to show how we can reduce the boilerplate to reach the same thing. So like we could
that's interesting.
we could maybe start with, I don't know, a change notifier that does the data fetching and that can notify listeners when the query is finished, and then at the end refactor to future provider to remove almost all the code.
Yeah, I feel the thing that is most valuable with this approach is if you get a solution for a problem that you never had before, you accept the solution, but you may run into the problems that the solution tried to solve to begin with. If you never faced a problem before, you cannot really understand why it is there. So if you say, okay, we have this problem, how could we solve this? Solve it first, so the user understands, okay, this is how I would do this. This is something I understand.
Yeah.
And then reason, okay, we did this, and this is my solution for this exact problem.
Yeah.
I think that is very valuable, and that would be very nice for docs.
In the dark doc of Riverpod, the documentation associated to each element of the API, if you go on the dark doc of any provider, each provider explains what's the use case of the provider. So like if you go on the documentation of future provider, it will tell you that it's usually used for fetching a request, fetching something for an API, or pagination, whatever. Even if you go on the documentation of family, it explains what's the concept of family, why you would need to use this kind of thing. I think one of the issues is that the current website doesn't show the providers, doesn't highlight the documentation associated to each provider individually, so people don't necessarily find it. And I think that would be one of the downsides of dark doc. It's like kind of hidden in the corner, and I'm pretty sure that few people use dark doc.
Yeah. Coming back to the Riverpod and how it works, I had somebody on Twitter ask, where does Riverpod actually store state? So Riverpod works by defining global providers. At first glance, it looks like the state might be in some kind of singleton, some kind of global variable, because you are defining the provider as global state. How does all of this work? Where does the state live? Why is the state where it is?
There is actually no global state in Riverpod, which is kind of the most impressive thing, in my opinion, with the architecture, where even if your providers are global, the state is not global. It's instead stored inside this provider scope widgets that we added inside our widget tree previously. And if we want to go more specifically into how it works, provider scope, what it does is that it creates an instance of the object called provider container, which doesn't depend on Dart and which doesn't depend on Flare, sorry, which is a pure Dart object that contains states for providers, and it exposes it to the widget tree using plain inherited widgets. And what this means is that, for example, if you were to do testing, you would typically create this provider container object yourself inside the test. And this provider container object contains method like read. So you can do container.read my provider to obtain the state of a provider. And so the basic idea behind this is that, one of the basic criteria for testing is that two tests should not share state, because that would be a bad idea. Like if you change the order of the test, you could have a different behavior. So that's so then your test will not be reliable. And so using this architecture, you could create your provider container individually for each state, such that two tests would not share state at all, which would not be the case with singletons or global states.
By the way, I really love the approach of having this provider container that doesn't depend on Flare. In my current project, I'm actually just started writing a CLI version of the project. And I was able to reuse all the dependency injection wiring, which I had set up before for the repository, for the HTTP client, and just reuse that in plain Dart, because all of the dependencies were wired up using the provider container. I didn't have to do some manual constructor injection, so that's a big plus. Another thing I really like, and I don't feel you emphasize enough, is because because you have these global providers, you get complete type safe access to the thing.
Yeah.
So, and all the IDE integration. Before with provider, you had to add this generic type. The compiler couldn't make sure that the actual type is in the widget tree, that you have access to it, that it is there. With the new provider, all you do is I think of the name, okay, of a repository. I just start typing repository, and it autofills to repository provider, which makes it just so much more productive.
Yeah, and it also makes sure that you cannot try to read something that doesn't exist, or like with provider, so many people faced provider not found exception because they use the wrong build context. But with Riverpod, you almost cannot have this issue. You can still face this issue if you're using like scoped provider, which is a very, very specific feature in Riverpod, which you probably don't care about. If you want to, the short story is that it's a re-implementation of the full features of inherited widgets with Riverpod, so you can scope them to a widget tree. But then, otherwise, outside of scope providers, you can do basic. You don't have these exceptions anymore, and it also solves these problems about. Like, for example, I don't really remember what I wanted to say. Sorry.
That's okay.
It may come back in the future.
That's perfectly fine. Yeah. So actually, you just talked about the scope provider, and there was a thing I was wondering about. I haven't tried using the scope provider yet, but most of the state typically lives at the top of the tree because in Flutter you have the routes. And if you want some state to be available on every page, on every dialog, you have to put it on top of Material App. I had an issue open on GitHub that I would like to have some way to share some sort of state between multiple pages, but right now with the current implementation, that is not really possible. So, but sometimes a Riverpod and providers also just used to provide a value to the sub-widget tree. For example, you have one page that doesn't navigate, that doesn't move around. It's just one page, but it has a lot of sub-widgets, and each of those sub-widgets has a lot of widgets, and you would like to have a value there without having to pass it down the widget tree to every single constructor. The scope provider, as I assume, allows us to add this dependency, which uses the new Riverpod API to inject the dependency. Is that right?
Yes, it is right, but you probably don't need to use scope provider to do that. You could technically have your typical provider, but just use it inside your specific page, and maybe even place the provider directly next to the implementation of your page and make it private. You could technically do that, especially considering now you have variables for your provider, so you can make them private if you want to, which is very powerful if you think about it. The use case of scope provider would more be about making theme, for example, so that you can override the theme on a specific part of the application, or maybe translations, or I don't know, very specific use case. Another common use case with scope provider is lists. So if you want to pass the ID of an item, instead of passing it to the constructor of the widget, you could expose the ID using scope provider, and then the items will obtain their ID using the Riverpod API rather than their constructor. The main benefit of that is that then your provider, then your widget doesn't receive any parameter at all, which means you can make it constant. So you can make it constant so that if you update wherever inside your list, your widget will not rebuild unless what it used rebuilds. So if you have, like, say, a list of 100 items, and then you add a new item, that means that the item count changed. But if your item count changed, typically what list view would do would be re-execute item builder for everything that is present in the list until reaching the end of the screen. So that would rebuild a lot of things for no real reasons, because nothing changed for them. But if you use scope provider to pass the ID, you can make your widget your items constant, and then they won't rebuild unnecessarily, because since they are constant, Flutter is clever enough to not rebuild them. So you can do this performance optimizations. But that's a very advanced use case, I would say. Like if you're just getting started, you don't really have to care about that and go back to it in the future.
It's super interesting. I hadn't thought about this potential issue and a potential solution about this. That's very interesting. Coming back to the scope and the scoped provider discussion we had before, for example, you have some sort of variable which you only want to have be accessible on this one screen, so you could make it private. How would you deal with, for example, initialization and tear down? For example, you have some heavy object, you have a connection to a database or some sort of heavy calculation that you don't want to maintain after the screen is, for example, destroyed, something else is pushed. How would you deal with this if it is not actually scoped to the screen?
One of the very powerful addition of the inherited widget mechanism that is implemented in Riverpod is the auto-dispose flag on providers. Basically what it does is that it's a slightly different implementation of when the widget is removed, we dispose the resources. Instead, what it does is that when a provider is no longer used, it disposes the resources, which means that technically, if you remove the page, that will automatically dispose the resources too. But that's slightly different in the sense that it's not scoped to the page. So if you, for example, you have two screens that you're using the same data, then if you close one screen, but the other screen is still open, that won't dispose the data immediately because it's still in use. And then as soon as you remove the other screen, that will automatically dispose everything correctly.
That is super interesting. Yeah, that sounds like a pretty solid approach.
Yeah. And an interesting aspect of that is that we can also combine providers. So we can also have this very big graph of different states. And so when you're using auto-dispose, the auto-dispose flag, it will automatically force you to have all the children in the graph of providers to also use the auto-dispose flag, because if a descendant is not using the auto-dispose flag, but a parent is using it, that would kind of be weird because it would be always kept alive. So so then you have this graph of auto-dispose objects, and that suddenly makes Riverpod very clever, like in the sense that all your graph of providers will still be in use, even if you're using only the leaf of your graph. And as soon as you stop using the leaf of the graph, everything will kind of destroy itself naturally without having to care about it.
That sounds pretty clever. Yeah, so touching upon this, we talked about this before, like the scoping, not the scoping where you declare providers. One thing I also really like is, for example, I have a repository, and if I want to provide this repository to the rest of the app, I don't have to go into, for example, my main file, create a new provider in my multi-provider and provide it in there, but I can just do it above the actual class. So if I, for example, say, okay, my repository now also needs a dependency on the network client, I don't have to move to do different files to do this. I can do it all in one place. And I really like the approach of having code that is modified together, be together. For example, if I modify the provider and one of its dependencies in the class, I also want to modify the actual provider which provides this class. So I really like this.
Yeah, we can even go one step further, and like now that providers are variables, we can even extract them into packages. So if you're splitting your application into multiple packages, you can, for example, extract all the logic for the home page inside a separate package to share it with different things. And you can extract the provider too, so that you just have to insert the provider scope widget at the root of your application. And it doesn't matter whether the home page is using providers or not. It will just work out of the box. You don't have to worry about inserting something inside your main application. And another benefit is also in testing. Like one of the downsides with provider is that you have to, when you want to do testing, you have to reinsert all the providers if you want to set to test a very specific widget. So that's quite a lot of boilerplate to add all the providers needed by your widget tree, Whereas with Riverpod, you can just add this provider scope widget, and then you don't really have to care about reinstating all the different providers that you need to use, and you can just override only the providers that you want to mock the behavior.
Yeah, you don't have to re-implement all the wiring which you are doing already, because the wiring is done implicitly.
Yeah, which is very important, because you likely want to test this wiring too. So if you have to copy paste it, that's not a good approach.
Yeah. That is, I think, always a good indication that the code might have a few bad smells if you have to copy paste stuff to get it to work.
So I really like this approach,
Yes, I do too. So I asked on Twitter what people would like to hear in this podcast, and the majority was examples. A lot of people said, of course, basic counter application can be easily done in pretty much any state management tool, whether it be stateful widgets or block. The counter example is a good way to start, but there is always a need for more. So in this segment, I'd like to walk through a few simple example scenarios, simple in a way to simple to understand, but from an architectural standpoint, maybe not too simple. And I would like to hear your thoughts and how you do this on those. So let's start off with something actually very simple. Just a bit more complex in the counter application, the classical to-do list application. But with the little twist that we also want to have items filtered, which I know we talked about is a very good example of provider.
It's actually already implemented on the Riverpod documentation. There is an open source implementation of it. It's just not associated with a tutorial that explains step by step how to do it. But if you go to todos.riverpod.dev, you will see a to-do application with filter and everything implemented in Riverpod.
Yes.
Yeah.
Do we still want to go over concepts, or would you rather
do that?
Okay, yes. So we have a simple application, to-do list. We want to be able to add a to-do item, remove a to-do item, and update a to-do item. Every to-do item is just the text and whether it's done or not done. How would be it doesn't have to go into the detail, because obviously listening to code is a bit harder to read it, but how would you architect this, and what kind of providers and why would you use?
Yeah. I think there are two big steps. There is the filter, which is one thing on its own, and then the just managing the list of to-dos. So first, for managing the list, that's a typical use case for a state notifier or a change notifier, depending on whether you want to use mutability or not. So you make a custom state notifier class, which expose, add to do, remove to do, edit to do methods. And that just expose a list of to-dos. Then you plug it into a state notifier provider or a change notifier provider, which then allows your UI to listen to the list of to-dos and do something on click or whatever to update this list of to-dos. So that's for the list of to-dos without filter. And then for the filter, using Riverpod, it's actually very easy to do to filter states. So the only thing you need to add is create a separate state for the filter for your enum, for example. So you can use a state provider, like we mentioned previously, which just stores the current state of the filter. So likely none by default. Then you plug it to your UI such that it changes when you change the filter state. And finally, you can combine your filter and your to-dos, your state notifier to-do list using a provider. And then inside your provider, what you do is you use this ref object passed to the provider and call ref.watch to-do list and ref.watch filter provider. And then you just do list.where and then filter accordingly. And this will automatically, I forgot. Once you've created this provider, what you do is inside your UI, instead of listening to the entire list, you now listen to this new providers that you've just created. And so with just this little change, now your UI will automatically filter things accordingly, and it will filter the list only when either you added a to-do or you change the filter state.
Mm-hmm. So the idea behind this is we could actually implement the filtering inside the state notifier. We could have a method called set filter level or set something like this, and then do the actual filtering in there too. But the idea behind this is the separation of concerns. Like you have your state notifier provider, your state notifier.
That's not really separation of concerns here. It's more about making it declarative, such that we have a single source of truth for the list of to-dos. Like this business object manage the list of to-dos directly, and we don't really want to mess around the official source of to-dos. We don't really want to change the public API about it to avoid like having to. I think I saw many questions on Stack Overflow where there is this mistakes where they updated the list of to-dos that they had when they changed the filter, but then when they go back to none, they realize, oh no, I lost my to-dos where they are. So
yes.
So it's like by separating things and using ref.watch instead of having all this logic inside state notifier. You could technically do that and have a big state notifier object that expose many different things like the filtered list and the row list and whatever. You could do that. But the issue is it's slightly more complex because you will have to deal with listeners. You will have to make sure that you're caching the value when you need to. Like listening to both the filter and the change on the to-do list could be quite complex. Whereas by using by splitting it into multiple providers and using ref.watch, it's very linear. You don't really have to bother about what happens when the state of the filter change, what happens when the list change. It's just done for you automatically without having to care about it.
I think the thing or the idea that would better encapsulate this is the single responsibility pattern in this case, because you would have this one component that its only responsibility is to manage a list of to-dos, to update and do all that stuff. It doesn't really have to do the filtering because it just has a single responsibility. And then you add something else, which has also a single responsibility. It gets a list of items and just filters it. The interesting part about this, it is very pluggable. Like if you want to change it, if you want to remove the filtering, you don't have to go into your class and remove lines of code and do your stuff. All you have to do, you just don't listen to the filter provider anymore, but instead the normal to-do list provider.
And another benefit is that it's also more performant in the sense that, especially if you're using immutable data, like if you're using immutable data, you may, if you want to have a single big state notifier object, your model will likely be quite complex. Like you will need to have the row unfiltered list of to-dos, and then you will have to have this filtered list of to-dos. But then when you want to do any edit, you will have to always clone the object. But that means that the larger your model is, the bigger the clone operation is. Whereas if you're separating it into multiple providers, you have less things to clone when you're updating the list. So it's technically slightly faster too.
Interesting. Okay, so I think that was a pretty good breakdown of the first example of just a simple list of to-dos. We've also the added feature of being able to filter. Let's move on to something a bit more complex. And the ideas or the app would be you have a list of items, just like in the to-do list. But in this case, those items are not as trivial and simple as to-do items. In this case, we can have one class which manages a list of to-do items because they're so simple. It's just immutable data which can be copied and changed. Let's have a case where each item is super complex. Each item managing its own vast and big state may do additional network calls in there to lazily load even more data, or just have a very complex interaction? I think putting that all in one class might be too much. How would you do this?
I don't really understand what you're explaining here.
So, for example, think we have a list of not to-dos, but of games. We have like 10 games. Each can be visible at the same time. Obviously, a game is very complex. You don't want to have all the game state of all the games in one class because every item is complex. How would you do this?
Okay. Yeah, so it's not just a list of DOM objects. It's a list of objects that may update independently that has different rules too. So it's not just the same kind of object. Okay.
Right.
So I think different approach is to have a separate provider for, like, when you have this kind of use case, you may want to, instead of storing the list of games, just store the list of IDs of games. And then so you can update just the IDs, add new IDs, remove IDs. And then the listening of the object is done separately. So the ID, you may want to use something like family. So you might want to create separate game provider that is either a change notifier provider or a state notifier provider, and use the dot family constructor to create your game instance based on the ID. Actually, I'm not sure.
I think that's
do you want to add new games at runtime?
Possibly. Like, imagine it not just being games. There are apps with just complex interactions within these items. Like, not all apps just have this dumb data. Sometimes it's just complex. So think of this game as being anything that is complex. So yeah, adding, removing, updating would be something that one wants.
I mean, the reason I'm thinking about it is that with games, they have completely different implementation. So it's a bit like, depending on the game type, you may use a completely different controller. So that's a very specific use case.
For example, it's always the same game, like it's Tetris or something, but obviously with a different state. Like
so it's different instances of the same game.
Yeah, that's an example.
Yeah, so in that case, the what I was explaining previously totally makes sense, where you have your list of IDs on one side, and on the other side you have your state notifier provider or change notifier provider dot family, and then it receives the game ID, because families are just providers that receive an extra parameter to do some extra fancy stuff. So here it's just the ID. You don't really care about the ID inside the game instance. It's just the ID associated to the game. And so your state notifier provider will create the game instance, so the Tetris instance. And then your UI will be able to, like, when you want to add a new game, what you will do, you will just push a new ID to the list. And then that will automatically update the UI that listen to all the IDs. So you may have a list view somewhere, which will update because you added a new ID. And then when you want to read the game associated to this ID, you will read the game provider that you created, which is a family. So you will have to do like watch game provider and then pass parameters to this game provider. So you pass the ID that you received previously from the list view. And so by doing that, that will, the first time you try to read this ID, that will create the Tetris instance automatically for you, and that will also subscribe to the Tetris instance such that when it changes are propagated.
And I also think that this makes a lot of sense because the object which manages the list doesn't have to load all the items and wait until like 5 instances of Tetris are loaded. It just says, okay, we have 5 items. We can distinguish between those items. And the actual loading, which may include a loading indicator or some sort of network fetching, can be done externally in these Tetris providers. So these can be, so again, single responsibility. We have one a list that is being managed, and we have one individual game that is being managed, which could also live on its own. So to make things even further complicated, because that's the thing I like, is okay, we have like 3 Tetris games, and now we want to implement some weird impossible game that accesses the state of another Tetris instance. Think you're playing Tetris on 3 tiles, and you want one Tetris to see, okay, if the other Tetris just spawned a cube, I want to spawn a something else. How would you do something like this?
Can you still add Tetris at runtimes?
Of course.
So how does the interaction between Tetris instance works? Like, what? How does it determine which Tetris instance does it want to use?
I mean, an example would be at the initialization stage, you would be select another Tetris instance, maybe via ID. So, or example, you always want to use the instance which is on top of it in the list. Just some heuristic.
I'm asking mainly because there is a very important part in state management, which I think is not used enough, which is unidirectional data flow. And providers kind of enforce you to use unidirectional data flow to make sure that your application doesn't lead to spaghetti code on the wrong run. So you need to think about how your object interacts. So in the case of you're only reading the previous Tetris instance, it's fine because it's just a linear list. So that's unidirectional, so you don't have a issue. So yeah, in this case, you can just, inside your game provider, which is still a family, you receive the ID associated as parameter, if you remember correctly. So since you have the ID as parameter, you could technically listen to the ID -1 to obtain the previous instance. So you could, like, using the ref object, you could do ref.watch game provider, and then pass your ID -1, and then you will be able to listen to the previous instance.
Interesting. I really like the fact that it's so easy to access all of this without having to worry about, okay, can I access this because am I above or below the other provider? Like things you would be having with the provider package where you have to think about this.
You will still have an exception if you try to do something that is not a unidirectional data flow. So if you have, if you're trying to read the previous Tetris and then the previous Tetris is trying to read the next Tetris, you will have an exception telling you that it's not possible because
it's a cycle and it would be infinitely updating, right?
Yeah, and then especially that's also why we can do some powerful things like the auto dispose flag, because since it's a unidirectional data flow, you don't have this cyclic dependency, so you know when you can dispose resources. Whereas if you had a cyclic dependency, you wouldn't be able to know, oh, okay, it's not used anymore. So yeah, Riverpod will not let you do very weird stuff. You have to be careful. And that's
always
also
good.
That's one of the biggest reason I'm working on a dev tool for Riverpod at the moment, where I'm extending the Flora dev tool. And so you have a new tab for Riverpod, which shows like your typical state management dev tool, where it shows the expanded view of an object. But it also has an extra tab where you see the graph of states. So you would see, oh, this provider depends on this other provider. And then you have this tree of states and see what happened when you update this provider, which other provider depends on it. And you also will likely see the widgets too at the same time. So you could like
I
jump
really
to
like
a specific
the idea.
widget. Yeah, I like the idea.
I feel like I feel like all the state management solutions could use a bit more love from the dev tooling direction, because you have all this state management things, but it's still kind of awkward to inspect the state, especially during runtime. And even if you are in debug mode, you first have to set a breakpoint. You then have to manually go through the variables and the references. Just having a way to have more information be visible with less effort, I think that could be very helpful.
And I think I'll give a shout out to the Google team. Like, I've already started working on the dev tool, and I've tried it, tried what's existing in the dev tool, and they actually have the possibility to inspect objects, Dart objects at runtime. So you are able to list all the properties and everything you want to implement a dev tool, which means that I was able to list everything we want to do and in a typical dev tool. So list all your properties and potentially update them. We can also update the state of your state from the dev tool. So you can click on something, toggle booleans, update strings. So yeah, the dev tool is very, very, very powerful, and I think it's quite underrated at this point. And maybe in the future, more people will contribute to the dev tool once they realize that they can do all this fancy stuff that typical applications in Dart would not be able to do.
Mm-hmm. Yeah, that is indeed super interesting. I didn't know you were able to do so much even during the runtime, but that's definitely something I'm super excited for. So
that's why I'm sure, Remi.
If anybody wants to know more, just follow Remi. I'm pretty sure once things are ready, you'll be able to, you'll know.
On the dev tool, I would say that at this current stage, I'm able to obtain all the different informations needed to show the dev tool, like the graph, and update these things. And the only remaining thing is making the UI pretty, because it's currently not very pretty.
Mm-hmm. But I mean, if you think about making stuff pretty, then I'm pretty sure you're at a stage where our stuff is working. So if it's just making it pretty, I'm pretty sure you'll be able to accomplish that.
Yeah.
So I think we are slowly getting to the end. Do you have anything to add, to say?
Yeah, I would say if you have any feedback about Riverpod, whatever it is, even if it's like, oh no, Riverpod is super bad, it's fine. Please tell me. I would love to get as much feedback as possible. Like, the only thing I've seen is people saying maybe thank you or something like this. So it's great to hear, but I love to hear also about what problems people are facing, so that maybe I can document it, or maybe I have some new features to develop. So if nobody is complaining, it's difficult to do my job, I can't really improve the thing further if nobody is complaining, because I don't know what to improve.
Maybe it's just so good that there is nothing to improve.
Yeah,
who knows?
It's very unlikely. I'm pretty sure that there are many things I need to improve. Like, for example, I sometimes when I randomly try stuff, I find bugs. So I'm wondering, is it that people don't report bugs, or is it that they didn't find it? And I always have this question at the back of my mind. Do people actually use the stuff I make? And I never know.
I definitely do. Okay, thank you so much for being on the show.
Thank you too.
For all the listeners, we'll have all the links. We'll have his Twitter handle and the ways you can follow him in the show notes. Thanks again for being part of the show, and
thank you for
have a good one.
Me.